In this presentation, I'll be explaining the working of a 4-quadrant chopper and its application, how 4-quadrant chopper can be used the movement of a hoist. That also will be explained. Now let us see the 4-quadrant chopper, that's also called type P chopper, 4-quadrant chopper or type P chopper, in which this is the circuit topology. There are 4 switches. It is named as, here marked as S1, S2, S3, S4. These are all controllable switch as such, and across each switch there are feedback diodes D1, and here across S2, D2 and D3 and D4, and there's a DC source voltage VSP, and the load is connected between these 2 points, and normally we'll be considering here as a DC motor load as such. Back EMF, armature inductance, armature resistance is neglected, that's why it's not shown here. Anyway, this represents the DC motor, and switches S1, S2, S3, S4, these are the feedback diodes. Therefore, this is a circuit topology. And 4-quadrant operation means, if you see the quadrant of operation diagram as such, here this is the 1st quadrant operation, this is the 2nd quadrant operation, this is the 3rd quadrant operation, and this is the 4th quadrant operation. In this is the current axis and this is the voltage axis in electrical plane. And in corresponding mechanical plane, this is the torque axis and this is the angular speed or velocity omega m axis. For T and omega, or it is current and voltage. If T and omega are both positive, you can say that product T into omega is positive. For T into omega represent the mechanical output power. Therefore, in the 1st quadrant of operation, the mechanical output power is positive, means that power is flowing from the DC, electrical power is flowing from the DC source into the motor. So it's converted into mechanical output power. Now that is called forward motoring. Since the omega, the polarity of omega represents whether it is forward or reverse. Therefore, if omega m is positive, we call it as forward. And if the product T into omega is positive, we call it as motoring. Therefore, looking into these 2 aspects, when omega is positive, omega m is positive, is forward. And when T into omega is positive, we call it as motoring action. Therefore, T means that is proportional to, of course, the current IA, and omega is proportional to the voltage. That's so this in electrical plane, this is the current axis and this is the voltage axis, average voltage axis. And this is in mechanical plane, this is the torque axis and this is the omega m axis. T into omega is positive means it is the motoring action, and if omega m positive means it is a forward. Therefore, this mode of operation is called forward motoring. Since omega m positive, forward, and T into omega is positive, motoring action. Therefore, this is called the forward motoring action. And similarly, we can, we'll be seeing the other one. This is called the, since omega is positive and the product T into omega is negative, it is called the braking action or regeneration, or that is called the forward regeneration, because omega is positive, forward, and the product is negative, it's the regeneration or braking action. Forward regeneration or forward braking action is taking place, regenerative braking. And in this case, the 3rd quadrant, if you again see that one, this is the torque axis, this is the omega m axis, or this is the current axis, or this is the voltage axis. The product is negative and negative, positive. That is for, again, T into omega is positive means it is a motoring action, but omega is negative, that is called reverse happens. Therefore, that is why the polarity of the omega, if it is positive, it is forward. If it is negative, it is reverse. T into omega will represent whether, if T into omega is positive, it is motoring action. If T into omega is negative, it is the regeneration. Therefore, in this case, since omega is negative, reverse, and T into omega is positive, it is braking. Oh, sorry, it is motoring. For it is called reverse motoring. And similarly, a 4th quadrant operation is that torque is positive and omega is negative, or current is positive, voltage is negative. So the product T into omega, we can see that one, it is equal to negative, and omega is negative. For since omega is negative, it is reverse. T into omega is negative means it is called a braking action, or it's called a regeneration. So this is a reverse regeneration, or this is a forward regeneration, and this is a forward motoring, and this is the reverse motoring. These are the 4 quadrant of operations. Now let us see the first one. DC motor is, and the thing is, DC motor is considered as the load as such. And here, 1st quadrant of operation, now to work it as a 1st quadrant operation, this is the thing, the switches that is to be controlled. S1 is being controlled at high frequency. S1 is operated, on-off control is done for the S1. And here, S4 is permanently kept on. In this case, in motor 1 operation, S4 is on, that is, it is on, and S4 is on, S1 is controlled here, and other switches, S2 and S3 are kept off. S2 and S3 are kept off. For the applying this one, the corresponding equivalent circuit is this one. Therefore, you are controlling the switch S1 and S4 is closed and other switches are open. Therefore, diode D2 comes across the load here. Therefore, this is the equivalent circuit corresponding to the first quadrant of operation and obeying this switch status. Therefore, here we can see that one in first quadrant of operation, we can have to get a voltage is because average voltage should be positive and average volt current also should be positive. Now, when the switch is on here, you can see that across the load you will be getting a positive because V is connected to here. Therefore, a average plus voltage we are getting. V plus V is coming here. And when switch is off here, because of the energy stored in the inductor, that will be driving a current in the same direction as this one through diode, but the voltage is equal to 0. Therefore, when switch is on, the voltage equal to plus V. When switch is off, the voltage equal to 0. And if you take the average voltage, it will be always positive. That is why it is working in the first quadrant. Voltage is always positive. Voltage is positive. Now see the current also. When switch S1 is on, here you can see that one from the source, the current is flowing like this one. One thing is that the positive voltage here and negative, this one is taken as the positive voltage. Plus here and minus here. Similarly, the current is in this direction, marked the one that is taken as a positive current. If you take an armature of the DC motor, this is A and this is A. When current is entering A, that is taken as a positive current. And similarly, the voltage plus here and minus current as a positive voltage. Therefore, in this case, when switch S1 is closed, the current is in the direction, or the current is positive. When S1 is open, also because of the energy stored in the inductor, that will be circulating a current through the diode. Again, the current is positive. Therefore, you will be getting always the average current is equal to positive. And the voltage, average voltage is also here positive. Therefore, it is working in the first quadrant. That is called forward motoring. Again, to tell that one, why it is forward means that omega m is positive. Because voltage is positive always. And motoring operation is why T into omega is positive. Therefore, the power is flowing from the DC source into the motor. Or energy, electrical energy is converted into mechanical energy. That's called the motoring action. Therefore, T into omega is positive. Therefore, in order to work this the DC motor in the first quadrant, forward motoring operation, the average voltage should be equal to positive. Similarly, the average current also should be equal to positive. Or torque is positive as well as omega m also equal to positive. That is called forward motoring. Or these are the switch status to work it as in the first quadrant. Continuing the type P chopper or quadrant chopper, to let us see the working of the second quadrant. Second quadrant operation means that if you see the mechanical plane, this is the torque axis, this is the omega m axis. Omega m is positive and torque is negative. The product T into omega is negative. That is why it is called the regeneration. But omega m positive, that's called forward. It's called forward regeneration. Also, it is called regenerative braking action, because reverse torque is produced that one, because the current direction decides the torque polarity. Since the current is negative, you'll be getting a reverse torque as such. Now let us see that one. In order to work in a second quadrant, the conditions of the switches are, we'll be switching off this S1, S3, S4. All are kept off. S1, S3 and S4. These are all kept off. And we are controlling only the switch S2. Therefore, the equivalent circuit is this one. S2 is this is a controlling switch, and diode D1 is of course, this is diode. Of course, D4 is and this is the motor equivalent circuit. And the voltage plus here and minus here is a positive voltage. Current in this direction is equal to positive current. But we can see that one, when switch is on here, circuit is like that. When switch is on here, see that one here, because of the the source as such, this inductor, there will be this one current through this one. The energy will be stored in the inductor because of this back EMF here. There will be a circulating current through this one, and that will be storing the energy. You can see that one. In that case, the current is negative. When switch is on, the current is negative, and the corresponding voltage is same as this 0 voltage because it is shorted by this switch. For the 0 voltage is there, but the current is, there will be circulating current in the opposite direction. That is happening when switch is, when S2 is closed. When S2 is open here, whatever the energy stored in the inductor, that will be trying to drive the current in the same direction, same as this one. Therefore, that will be here plus and here minus comes that induced voltage as per the Lenz's law. That will be plus here and minus here, or that will be driving, since it is plus here, this will be driving current through this diode. Therefore, when switch is off here, there will be a current in this direction, and in that case, the current again negative. But since it is connected to this point, is connected to the plus terminal, here the voltage is equal to V. Therefore, when switch is off, this voltage voltage across the armature, we can say that one V0, which is equal to positive, but the current is negative. Current is flowing that one, or that is leaving from the armature. Or we can say that once since the current polarity is reversed, a reverse torque is produced. A negative torque is produced, or negative torque means nothing but braking action is taking place. Therefore, during this braking action, whatever the energy stored in this motor, that will be driving back to the source. That's called the regenerative braking. Therefore, that is operating in the second quadrant, in which the voltage is positive, average voltage is positive, but current is equal to negative. The product V into I, that is the negative. Therefore, the power is flowing from the motor side into the source, or that's called the the forward regeneration. Why it is forward means that here omega m is positive. Therefore, the direction of omega represents whether it is forward or reverse. Therefore, that's forward. But of course, the product T into omega m is negative. That is what regeneration happens, or braking action is happens. Therefore, it is called forward braking or forward regeneration, second quadrant of operation. And these are the status of the switch. S1, S3, S4 are kept off, and S2 is operated at high frequency. When it is on, 0 voltage. When it is off, you'll be getting the voltage V. And by controlling the duty ratio of this one, you can control the average voltage across the motor, so that the speed of the motor can be, of course, that reduction, because actually the power is be flowing from the motor into the source. That's called braking action is taking place. Therefore, V0 is positive and I0 is negative. Always the current will be in this direction, opposite to this one. And that is why the reverse torque produces, or braking action is taking place in the second quadrant. That's called forward regeneration or regenerative braking. That is the second quadrant of operation of the four quadrant class type P chopper. Therefore, in second quadrant of operation, you can get a reverse torque as well as a positive omega m, and that is why it is called forward regeneration. Now, continuing the four quadrant type P chopper in the third quadrant of operation. Let us see the third quadrant of operation, in which we can, looking from this one, you can see that one here voltage is negative and current is also negative. Or you can say that in mechanical plane, here it is omega m is negative and torque is negative. The product torque into omega m is positive. That is why it is the mechanical power output is positive, or power is flowing from the DC source into the motor, or motoring action is taking place. Since T into omega is positive, the power is flowing from the DC electrical power is converted into mechanical. That's called a motoring action. But since this is negative, omega m is negative, we call it as reverse motoring. The motor will be rotated in the reverse direction, or that's called reverse motoring. And here the corresponding status of the switches are always, to make the third quadrant to work it, S3 is, in that case, we can see that one S3 is operated on and off. Here S3 will be operated at on and off control. And S1 and S4 are kept off. S1 and S4 are kept off. These are kept off. And these are being controlled. And S2 is, you can say that one, S2 is kept on. S2 will be kept on. Therefore, these are the status of the switch to make to work in the third quadrant, which is equal to reverse motoring. And the corresponding equivalent circuit is shown here. Therefore, S3 will be controlling at high frequency, and S2 is permanently kept on during this region of operation, and other switches are off. That is, S1 and S4 are kept off. Therefore, this is the equivalent circuit, and this is the motor. Again, I'm telling that plus here and minus here is the positive voltage, and if the current direction is in this one, it is called a positive current. Now, let us see that one. When switch is on here, what happens at? When switch is on here, the positive terminal of the source is coming here, and negative, or you'll be getting a negative voltage here. You can see that one, plus here and minus here, or a negative voltage comes when switch is on. And here, and when switch is off here, again you can see that one, here is voltage, diode D2 will be conducting, and you will be getting a 0 voltage here. But in this case also, the current is opposite. When S1 is on, you'll be getting a positive voltage. At the same time, there will be circulating a current in the negative direction. Therefore, I will be negative and I0 will be negative, and V0 will become negative. V0 also will become negative. And similarly, when switch is off here, diode will be conducting. Since diode is conducting, here we'll be getting this negative terminal. Of course, it is shorted here. We'll be getting a 0 voltage here. And of course, the current is in this same direction, opposite to this I0. Therefore, negative current happens. Therefore, the current through this load motor is always negative, but voltage will become, voltage also here negative when it is closed, and when it's 0 when it is open. Therefore, the average voltage will be always negative, since the depending upon the duty ratio, you can vary the negative value of the average voltage across the motor, and the current is always negative. That is why it is voltage is always negative and current is also negative. Or we can say that one torque is negative and omega m is also negative. T into omega m is positive. That is why it is called motoring action. Since omega is negative, it is called the reverse. That's the reverse motoring action is taking place in the third quadrant of operation. And these are the switch status, like as I already all know, S1 and S4 are kept off. S2 is kept on, and S3 is operated on off. This is the switch that is being controlling for this to work it as a third quadrant. And in that case, we got that the average output voltage is negative. Similarly, average output current is also negative. That is working in the third quadrant of operation, or it's called regenerative motoring. Therefore, it is the reverse. Since it is, why it is reverse means omega m is negative. That is why reverse. And why it is motoring means that the product of T into omega, that decides the power. T into omega is mechanical output power, that is positive, meaning that the power is flowing from the source into the to the load, mechanical load power. That is electrical energy is converted into mechanical energy, but the rotation is reversed. That is why it is called the reverse motoring operation. That's the third quadrant of operation. Now let us the fourth quadrant operation, continuing that one, type P chopper. In the fourth quadrant, let us see the fourth quadrant, that one. The switches that are the fourth quadrant means voltage is negative and current is positive. Or you can say that torque is positive and omega is negative. So for T into omega is negative, the same time omega also negative. Since omega is negative, we call it as reverse. And T into omega is negative, it is called the braking action or reverse, regeneration. That is why it is called reverse regeneration. Reverse generation. That is reverse, why it is means omega m is negative, and regeneration or braking action because T into omega is negative. Therefore, this is the reverse regeneration. In order to get a negative voltage and positive current, correspondingly the circuit diagram, that one is, these are the switches position, that is S1, S2, S3 are kept off. S1, S2, S3, these are kept off, and S4 is operated at high frequency. That is, this S4 is operated at high frequency. Therefore, the equivalent circuit of this 4-quadrant chopper corresponding to these switching condition is this one. This is the equivalent circuit, and in that case, we can see that one, when the switch is on, what is the voltage here? When switch is on, let us see that one. When switch is on here, diode is conducting, and then there will be a circulating current, this one, and the voltage across this one is equal to 0 because this is conducting. The voltage across the motor equal to 0. The same time there will be a positive current because diode D2 is conducting. There will be current is positive, but voltage equal to 0. And when switch is off here, whatever the energy stored in the inductor will be driving a, or that because of the inductive energy, that will be driving a current with a here plus and here negative. The current in the same direction. But here, since the D2 will be, D3 will be conducting. Therefore, the path is like this one. D2 is conducting when S4 is off. When S4 is off, the path is like this one. Or you can say that this terminal is connected to this one, or here this terminal is connected because here the positive comes here. Positive voltage comes here, negative, or negative voltage across the, because what we are taking plus and minus is the positive voltage. But here we are getting a negative voltage with respect to this one, or reverse voltage. Negative voltage, armature voltage is negative, or the load voltage is negative, but the current is positive. Therefore, the current is positive, but the average voltage is equal to negative. That decides the torque is positive, but omega m is negative. T into omega is negative. That is why it's a regeneration. But omega is negative. That is why it's called reverse. That's why reverse regeneration. And these are the switching positions. So what are that? Already we have seen S1, S2, S3. They are kept off. And S4 is operated at high frequency, and in that case we see that one average voltage is negative. For when switch is on, you will be getting 0 voltage. When switch is off, you will be getting a negative voltage. Therefore, average voltage will become negative, and average current, always the current is in this direction. That is why positive current is getting, average current is equal to positive. That is, it is working in the third quadrant, in which torque is positive and current, of course, omega m is negative and T into omega is negative, and that is why it is called reverse regeneration. That is the fourth quadrant of operation of a 4-quadrant chopper. Now continuing the 4-quadrant chopper, class C chopper, as we have already seen that one, for the first quadrant operation, S1 is operated at frequency. Therefore, the corresponding diagram shown here. In that case, it is called forward motoring case. Therefore, electrical power is transferred into the load, mechanical load motor. Therefore, we can see that one here a positive voltage is getting. Similarly, the current is also positive. Therefore, we are getting a forward motoring action. And the second quadrant operation will be S2 is operated at high frequency. On-off control is done for the S2 here. And in that case, it is called the forward and it braking action or regeneration. Forward braking or the power is flowing from the motor into the source or regenerative braking is taking place. And here we can see that the polarity of the voltage as such. Here we can see this is the current polarity is negative, but voltage polarity is positive, plus and minus, but the current polarity is now reversed. For the torque is reversed, at the same time omega m is positive. That's called the forward regeneration. T into omega is negative, forward regeneration, or it's called the regenerative braking. That's the second quadrant of operation. In that one, S2 is operated at high frequency. And for third quadrant of operation, this is the case when S3 is operated at high frequency. And this is the correspondingly, this is a motor is called the reverse motoring case. Here you can see that one, the voltage polarity has been reversed here. Here plus and here minus we're getting. The same time, we can see, the current polarity is also reversed. Current polarity is in the opposite direction. Since voltage and current are reversed, the product that will become positive, voltage and current. Or similarly, torque is negative, omega m is also negative, T into omega is positive. But since omega is negative, it is called the reverse. Therefore, this is a reverse motoring action. That is when S3 is operated at high frequency on off in the third quadrant of operation. And in the fourth quadrant of operation, you can see that one S4 is operated at high frequency or on off control is done for S4. And in that case, correspondingly, we can see that one voltage is negative. Here again, voltage is plus here and minus here. And current is positive. Current is in this direction. Since current is positive, torque is positive. Since the voltage is negative, omega m is negative. Therefore, T into omega is negative, or that is called a regeneration. The same time, the omega m is negative, it's called a reverse regeneration or reverse braking action is taking place. That is the fourth quadrant of operation. Therefore, these are the switches to be controlled in the first quadrant. S1 is controlled. Second quadrant of operation, S2 is controlled at high frequency. And S3 for third quadrant, S3 is controlled. And for the fourth quadrant of operation, S4 is operated at high frequency of this switch, or these are the four quadrant of operations. Now let us see the application of a four-quadrant chopper as such. The four-quadrant operation of a motor that is driving a hoist load. Let us see that one. Therefore, that is here. The motor is coupled to that consists of a rope wound on a drum coupled to a motor shaft. That is, there's a motor shaft to that one. This drum is coupled to that DC motor shaft, and in that one end of there's a rope is there. The motor shaft, there's a one rope is there, and one end of the rope there is a counterweight is there. It's called the counterweight, and other end of that one, that is the cage is there, which can be loaded or unloaded. That is, this is a cage on the other end of the rope, and this one is the counterweight. Normally, the selection of the counterweight is that one. The rule is that one. The weight of the counterweight is more than unloaded cage. The counterweight is more than unloaded cage, and that is less than the loaded cage. This is unloaded cage is this one. This is unloaded cage. Therefore, the counterweight will be more than unloaded cage, and that will be less than the loaded cage. That is the normal way selecting the counterweight. Therefore, here one end of the rope is tied to the cage. This is a cage that is to be moved up and down to the cage, which is used to transport man and material from one level to another level. This is a cage. Through that one, you can shift the man or material from one level to another level. That is the cage here. And the other end of the rope, this is a rope on the drum, and the other end of the rope has a counterweight. This is the counterweight. And the weight of the counterweight, that is the weight of the counterweight, is chosen to be more than the weight of the empty cage. The weight of this one is more than the empty cage, and that is less than the loaded cage, or that is the more than the counterweight is chosen to be more than the weight of an empty cage, but less than the fully loaded cage. This weight is less than the fully loaded cage, and that will be more than the unloaded or empty cage. Therefore, the motor speed is taken. One concept what I am following is that one motor speed, that is angular omega m. Omega m is positive when it is rotating the forward direction. That is when it is rotating the forward direction, means it is rotating the anti-clockwise direction. That is, this is the anti-clockwise direction. When it is rotating in this direction, omega m is taken as positive. And if omega m is negative, motor drives the reverse direction, it's the clockwise direction. That is, if the omega m is negative, it is the clockwise, and if it is positive, it is the anti-clockwise direction. Similarly, the torque also, that is the rotational force, that's called the torque. When the torque, if it is anti-clockwise direction, that is taken as positive, and if the torque produced is opposite that clockwise direction, that is taken as negative. T is if T is clockwise, if clockwise direction, T is taken as a negative. Therefore, these are the polarity concept that we will be following for the regarding the torque polarity as well as the omega m polarity. Omega m polarity means omega m is anti-clockwise, it is taken positive. If it is clockwise, it is negative. Torque is anti-clockwise, it's positive. Torque is clockwise, it is negative. That is the way in which we'll be fixing the polarity of torque and omega m. Therefore, in order to make it first quadrant operation, second quadrant operation, third quadrant operation, and fourth quadrant operation, that depends upon the polarity of the torque as well as omega m. And as I already explained, if both omega m and torque are positive, it is working in a forward motoring operation. If torque is positive and omega m is torque is negative, omega m is positive, we'll be getting into the of course forward regeneration or forward braking operation is taking place, and this is the forward motoring operation, and this is the reverse braking operation. Let us see one by one. Therefore, these are the four quadrant of operation, like forward motoring, forward braking or regeneration, or reverse motoring and reverse braking. Now let us see the first quadrant of operation. How first quadrant of operation means? This is the first quadrant of operation in which the purpose is that loaded cage, here either material or man, whatever the loaded cage is loaded, that is to be raised upward. That is the purpose of that. That is, in that case, what should be that one? Here we can say that since the weight of the loaded torque is more than the counterweight, as we have already seen that one, the load torque will be, the net load torque will be in this direction, or clockwise direction load torque comes. Therefore, in that case, always the motor torque will be opposite to the load torque. That is the concept. Always the torque to be produced by the motor torque should be opposite to the load torque. Therefore, in this case, since this cage weight is more than the counterweight, load torque is in this direction or clockwise direction. Therefore, the motor torque should be in the T is the motor torque, that should be in the anti-clockwise direction, meaning that, as I told you, if it is torque is anti-clockwise, it is positive. Another one is that since the counterweight is moving upward here, you can see that one omega m is also anti-clockwise, or omega m is positive and T is also positive, meaning that T into omega is positive, or mechanical power output is positive, or that is called forward motoring operation. Therefore, during the forward motoring operation, the loaded cage is moving upward. The loaded cage is moving upward, and the loaded cage weight is more than the counterweight. That is why the load torque acts the clockwise direction. Therefore, the load torque is acting in the clockwise direction. Always the motor torque, T is the motor torque, that will be opposite to the load torque. So the motor torque will be in the anti-clockwise direction. Since the load cage is to be moved upward, since this is to be moved upward, omega m is also anti-clockwise direction. Therefore, that is also positive. Therefore, the motor torque is positive, and omega m is also positive. T into omega m is positive. Similarly, omega m is positive. Since T into omega is positive, it's a motoring action, and omega m positive, it's called a forward. That is why it's called a forward motoring operation is taking place in the first quadrant. Whenever the loaded cage is moving upward, it is called the first quadrant of operation. Therefore, in a lift or hoist, when man or material is moving upward, the motor is operating in the first quadrant. That is forward motoring operation. Now let us see the second quadrant of operation. Second quadrant of operation, let us see that one here. This one here. In that one, here the second quadrant of operation here, actually it is the unloaded cage is moving upward. There's no persons or materials here. This unloaded cage is to be moved upward. As I told you, the counterweight is more than unloaded cage. Therefore, we can say this weight is more than this one, means that load torque will be in opposite, anti-clockwise direction. Load torque will be in anti-clockwise direction. I told you, always motor torque will be opposite to the load torque. Therefore, the motor torque will be in the clockwise direction. Motor torque will be in the clockwise direction. Clockwise direction means negative. As I told you, if it is clockwise torque is there, it is negative. And similarly, since the the empty cage is to be moved upward, omega m is, this is to be moved in this direction, omega m is positive. Therefore, we'll be getting in that one, omega m will be positive, and the T is negative, or T into omega m is T into omega is negative and omega m is positive. That's called forward braking operation is taking place in the second quadrant of operation when a unloaded cage is moving from the lower level to the upper level. The operation of this one is the second quadrant, or it's called the forward braking operation. Therefore, empty cage moving upward, that is, since the counterweight is more than the weight of this one is more than this one, the load torque will be acting in this direction or anti-clockwise. So the motor torque will be so the load torque is anti-clockwise. So the motor torque will be always opposite to the load torque, which is equal to clockwise. Since the empty cage is moving upward, omega m is also anti-clockwise. This is moving upward. Omega m is also equal to anti-clockwise. Therefore, omega m is anti-clockwise. Torque is clockwise, means torque is negative. Omega m is positive. Therefore, T into omega is negative, or omega m is positive. Therefore, it is called forward. Why it is omega m is forward? The product is negative, that's called braking. Therefore, that's called forward braking operation taking place when an unloaded cage is moving from a lower level to the upper level. Therefore, the motor is working in the second quadrant to bring a unloaded cage unloaded cage from one level to the upward. This is working in second quadrant. That is this operation, or it is called forward regeneration. Now let us see the third quadrant of operation. Third quadrant of operation is this one. This is called reverse motoring. This is called the reverse motoring operation. Let us see what that one. In that one, what we are moving is that the unloaded cage is moving from the higher level to the lower level. Unloaded cage is moving from the upper level to the lower level. Again, the counterweight is more than the unloaded cage. So since the counterweight is more than unloaded cage, we can then torque is the load torque is anti-clockwise direction. Load torque is anti-clockwise direction. Always motor torque is clockwise direction. Therefore, the motor torque is clockwise means that torque is negative. Torque is negative. The motor torque is clockwise direction means torque is negative. Now let us see that one. Omega. Here this is moving downward. Unloaded cage is moving downward means omega is again clockwise. That's also negative. For omega m is negative. Similarly, T is also negative. T into omega is positive. That is why it is called motoring action. But since omega is negative, it's called a reverse motoring. Therefore, in this case also, the power is flowing from the source into the motor, but the motor is rotating in the reverse direction. Therefore, whenever the unloaded cage is moving from the upper level to the lower level, when lift is moving from upper level to the lower level, that motor is working in the third quadrant, or reverse motoring operations taking place. Therefore, here, empty cage is moving downward. Empty cage is moving downward. Since the counterweight is more than the empty cage, this weight is more than the empty cage, the load torque is acting anti-clockwise direction, because this weight is more than the load torque is acting in anti-clockwise direction. So the motor torque will be in the clock. Always motor torque will be opposite to the load torque in the clockwise direction. Therefore, since the empty cage is moving downward, omega m is also in the clockwise direction. For both omega m as well as Tm, both are clockwise. Therefore, both are negative as per our concept what we discussed. For T on the omega is positive, but omega is negative. That is called reverse motoring operation is taking place. Therefore, whenever a cage, unloaded cage is to be moved from the upper level to the lower level, the motor is to be operated in the reverse motoring region. That is, torque into omega is positive and omega m is negative. This third quadrant of operation, reverse motoring. Now let us the last quadrant of operation, like fourth quadrant of operation, that's also called reverse braking. Reverse braking, this one. In that case, what we are moving, the loaded cage is moving from the upper level to the lower level. Since the loaded cage weight is more than this one, in the fourth quadrant of operation, the loaded cage is moving from the upper level to the lower level. Again, the loaded cage weight is more than the counterweight as per our assumption. Or here, since this weight is more than the counterweight, the load torque will be in the clockwise direction. The load, because this weight is more than this one, the load torque will be in the clockwise direction. Therefore, the motor torque will be always opposite to the load torque, which will be in the anti-clockwise direction. The anti-clockwise torque is taken as a positive. That is why torque is positive, but the movement of this loaded cage that is moving downward here, we can see that one omega m, that is in clockwise, or omega m clockwise means omega m is negative. Therefore, omega m is negative and torque is positive. T into omega is negative. T into omega is negative. Omega m is negative. Since T into omega is negative, it is called a regeneration. And since omega is negative, it's called a reverse. For it's called reverse regeneration or reverse braking operation, called regeneration or braking operation. Therefore, in quadrant 4 operation, which is called the reverse braking, loaded cage is moving downward. The loaded cage is moving from the upper level to the lower level, when lift is moving from one level to lower level, and the loaded one, and the loaded cage is moving downward. Since the loaded cage's weight is more than the counterweight, this weight is more than the counterweight, you can, that load torque is acting, the load torque is acting in the clockwise direction. Therefore, always motor torque will be opposite to the load torque. So the motor torque will be in the anti-clockwise direction. It will be opposite to anti-clockwise direction. Since the loaded cage is moving downward direction, that is, this is moving from upper level to the down. So the omega m is in the, the clockwise direction. Omega m will be in the clockwise, or omega m will be a negative, and the motor torque will be positive. Therefore, in fourth quadrant of operation, the motor torque is positive and omega m is negative, and the product T into omega m is negative. That is why it is called regeneration or braking operation. And since omega m is negative, it is called a reverse. Therefore, in fourth quadrant of operation, it's called a reverse braking operation. That is happening when the weight, the loaded cage is moving from one level to the lower level. Therefore, that is the fourth quadrant of operation. Therefore, when we are considering a hoist or lift here, the movement of the lift involves all these four quadrant of operation. That is, from an loaded cage is moving upward, it is the first quadrant of operation. When an unloaded cage is moving from, and that is moving from lower cage, lower level to upper level, it is the forward regeneration. And when the unloaded cage is moving from the upper level to the lower level, it is the reverse motoring. And when a loaded cage is moving from the upper level to the lower level, it is the reverse braking or reverse regeneration, because omega m is negative. It is called reverse braking operation is taking place. Therefore, these are the this is an example of application of DC motor for the lift or hoist to make it in the fourth quadrant of operation.